but I'm talking to you now from Australia. And my field of research is cloud forensics, as well as the forensics with the Internet of Things. And today I'm going to talk to you about one of our work of creating a logging model or a logging framework for enabling digital forensics in IoT, in an IoT cloud connected ecosystems. Now, I will just briefly go through the outline. I will introduce the IoT forensics. I will describe the background and problem description. And then before diving deep into the contributions of this work, which is described in bullet point 4 to 6. And finally, I can conclude it and open up the floor for question and answers. And why IoT forensics? IoT, as you all know, as an introduction, digitizes physical assets. It connects things to things and things to the people, and forming a network of billions of connected devices. And there has been a much larger growth in the volume of the deployed devices around the globe. And many research and predictions indicates that there could be more than 20 billion devices, and that could double within another 5 years. What all this thing is doing is that as much as there is an increase in the volume of the connected devices, it also increases the footprint for security vulnerabilities, hence malicious attacks, and hence the importance of securing those devices as well as making those devices capable for forensic examinations in the future. To give a volume of or the magnitude of the volume, and the motivation behind this work is that here I'm referring to one of the recent work of Nesheng et al., where they conducted a exploited vulnerability across the globe. They conducted a case study in 169 countries, across 39 business sectors, and across 20,000 nearly IoT devices to find out that more than 66,000 of those devices had illicit activities reported, or they were malicious activities. So the picture here, what I'm showing, gives a distribution of those malicious activities, and hence the importance of securing those devices as smart objects, as well as enabling those devices forensically capable so that one can conduct a digital examinations on the logs and the data that is being generated as well as on those devices. To give a background info, forensics is a post-incident activity, and IoT forensics is the same thing, and it can be considered as a subdivision of digital forensics. And the forensics has got the same purpose and intent. Wherever it is to find out the culprit behind illegal action. IoT forensics can be divided into 3 subsections. One is to do with the cloud forensics, and you may ask why cloud forensics here? Because IoTs are characterized by low storage, and most of the information will be stored in the cloud, and hence the challenges and the issues that is related to the cloud forensics also equally applies, and that is then becomes a part of IoT forensics too. The second component is network forensics, which deals with the evidence available in the network logs, which can be collected or extracted, and IoTs uses diverse set of network communication protocols. And the third one is the device level forensics, where it involves the evidence collected from the IoTs. Now, the actual coming to the contributions of this work, the number one objective is that we are addressing and summarizing the IoT forensic challenges and deriving the IoT forensics requirements. And number two, then we are proposing an event logging framework and a data collection model for specifying the log architecture, and also clearly describes what are the parameters to log and when they should be logging and how it should be logged. And finally, we also propose the log collection design stack for building and forensically enabled IoTs. To list IoT forensic challenges, there are few. There are many, but I'm just passing that through quickly in order to save the time. The physical location of the IoT is very difficult, and hence to find out where the evidence has actually been located, or the evidence location. The size of the object being very small is also a process problem of the classical method of search and seizure. In any forensic activity, first thing the forensic practitioners do is a search and seizure, and with IoTs, it is a big challenge. Identifying, there is a lack of what you call certified tools for uniquely identifying IoT. The volume and the velocity of the data is too much, causing raising up to big data volumes. And as mentioned, the sizes can be very small. It can even reside inside a human body. And there is no standardized architecture, so many companies produce their own set of things and forming heterogeneous devices. They use numerous communication protocols that gives rise to what we call as a blurry network boundaries or edgeless network boundaries. And there is a lack of certified forensic available tool to extract evidence from these heterogeneous devices. And IoT has got only limited storage and computational power, and as a result, there is a potential chance of losing the evidence unless it is being collected and archived elsewhere immediately. And there is also a lack of cross-border laws, applications, which can be, or a legal framework that can be applied across the border, and it can, and so as to get those evidence wherever it is being stored. Now, forensics. Talking about the forensic requirements, as mentioned earlier, forensics is a post-incident activity. So, classically in digital forensics, there are few cardinal questions that is being asked. Those cardinal questions are: what has happened? Clearly describing the sequence of events. Then, when did the event happen? In an unambiguous timeline, when the event happened. And the third point is that how did the event happen? The method and process of executing the incident. And finally, who did it? The individual behind the action. So these are the key principal questions that is being asked in any forensics. And if you are able to formulate a logging mechanism which then can answer these cardinal questions, that would solve a lot of the questions or a lot of the problems related to or making the system forensically enabled. So from these cardinal questions, and also looking at the IoT forensic challenges, as well as the cloud forensic requirements and challenges, we derived the following as the key IoT forensic requirements. One should be able to recreate the incidents. That means that it's possible if when all the events are logged, when IoT changes its state. One should be able to fingerprint the IoT along with the geolocation. One should be able to connect the action to the doer to find out who is the culprit behind the action. One should be able to map the event across a timeline clearly. And there should be clear separation of IoT events that is recorded per IoT so that it can be extracted per IoT basis. So these 5 requirements clearly explains what, how, who, when, and where the event has happened, and answers the key questions related to the forensics. In addition to that one, the other forensic requirements can be summarized as: the log should be, one should be able to collect the logs from the archive whenever needed. One should be able to go beyond jurisdictional boundaries. One should be able to establish the trust, confidentiality, and integrity in the logs. And the logs, it should be easy to interpret, and it should be based on factuals and the facts. So these forms the key forensic requirements. Now, the other part of my presentation today is what are the things should be logged such that it supports forensics. One, of course, the unique IoT ID to identify the physical ID of the devices, the geolocation where the IoTs are physically located, the timestamp, the user ID, and application/session ID. Why application and session ID? Most of the time, what happens is that an event would have been generated by the IoT due to an execution of an applications, and there could be multiple sessions within the application as well. So the combination of the application and session ID helps to prove the provenance factor along with the user ID. Then the severity, the impact of the incident, and of course the data that describes the event, the business record, use case events, operational data events, or security events. And when those legal events should be logged, it should be logged whenever the parameter changes a state, whenever no operation data events like error values, start, stop, and restart events. Too many restarting could be a malicious activity. The configuration data changes whenever it changes must be logged. For example, here, an IoT probably would have been programmed to trigger or send some sort of alarms if the value change varies between a certain minimal and maximum threshold values. And if those threshold values are being changed, that must be reported immediately. Otherwise, it can result in serious consequences. Security events, log in, log out, periodic object identification is critical because a malicious activity can silence IoT and take it out of action. Being the nature where it can be deployed anywhere, it can be susceptible for physical attacks as well. So that should be logged. Compliance events. IoTs probably they are deployed in many kind of health sector or any other industrial sector is strictly controlled by regulatory regime. So that regime, that regulatory rules specify what are the events that should be logged. Those events should be logged too. Another important fact is that recertification events. Periodic recertification or recalibration of IoT must be done, stipulated by the industrial regulations, and that must be logged. And the recertification ensures the quality of the devices, as well as it also ensures the IoT
Dear
is doing what it
presenter,
is being.
just have 2 minutes left.
Okay.
Yeah.
Thank you. I will just pass through it. So those recertification events must be logged too. How it should be logged? Through synchronized clocks, reliable two-way protocol to ensure that no data has been logged, encrypted data to ensure the confidentiality and integrity, compressed data and normalized data for other needs. And here I am just presenting the design stack of that is a third objective, where the lower tier of the thing, that is the event layer and the protocol layer, can be designed into and built into the IoTs, which is basically the event generator and the log formatting factor, and the protocol layer transmits data to the cloud services, where in the cloud service, it does an archive or secure storage of all the logs that is coming in. The application layer and the presentation layer deals with the forensic applications, as well as the data visualization and extracting tools to do the forensics on those logs. So this is the design stack which I'm presenting over here. Now, finally, to conclude within my time, in this work, what we are presenting is an IoT logging framework and a log collection stack which can be designed into the IoT so as to make the IoT forensic ready, or to make that enabling the IoT forensics readiness. And we also are described in this particular thing what are the parameters that should be logged, specifying what, who, when, where, and how those items should be logged, and clearly explained a design stack for those to make it happen as well. So let me conclude now, and I am open up for questions. Thank you.
Yes, thank you. Thank you for your presentation. It was good. It was very good.
Thank you very much. So anyone having any question? Please raise your hand. Okay. It's not a question. I'm just asking one thing. I mean, what type of encryption algorithms used for this purpose?
Well, there are AES-256 encryption supported by certain types of IoTs, which is manufactured by various companies. So in our model, what we were doing is that we were that is under implementation. That is the next part of this particular work as well. We were planning to use those IoTs as when we were making the theory proven, using those devices which were supporting AES-256 encryption.
Okay. And I mean, any planning about data cleaning process?
Oh yes, of course, it's an important thing, and that is a part of this
because it's a huge
in
part,
between the data cleaning process. Yes, that
yeah,
is
once
true.
we're talking about human to human or human to computer, there is a trust
Yeah.
issue, and all these things comes into the picture. So initial data
Yes.
cleaning process, I think, is a major challenge.
Yes,
So,
yes.
any planning?
Actually, that was part of my slide, and when I was running out of the time, I actually removed it or hide it away. And there is a data cleansing layer that is, in between after the protocol layer, as you can see over here in my screen, that is called data sensing and collection services in the sensing layer.
Because
when
it's
the data is
coming
being
from
collected.
multimodal sensors. So once the multimodal sensors are there, so there is a huge problem of data, I mean, cleaning process. Okay, thanks. Thank you.
The quality control and data cleaning is happening here.
So your next stage is you are trying to plan for the modeling for this entire
for the modeling, yes.
Okay, okay.
Thank you. That is very valid, and thank you for bringing it up. And I could at least now show that part which I purposefully removed from my or hide away from my slide when the time was running out.
Okay, no problem. Thank you. Thanks.
Yeah.
Thank you.
Thank you.
So we have our next presenter, that is Nishant Virakun. I have unmuted you, sir. Are you able to hear me?
Yes, thank you very much.
Yes, you can begin with the presentation.
Sure. Good morning to you all. First, I would like to thank you for giving me this
You can also start sharing your screen. Your screen is
Sure.
Yeah.
I'd like to thank you for giving me this great opportunity to present my research work in this distinguished forum. I'm N.S. Virakon from Sri Lanka, and just a minute.
Yes. Yes. It's
Can you
visible
see?
now. Yes.
Right.
You can begin, sir.
My research work is related to Wi-Fi home area networks, especially focusing on delay characteristics of smart grid traffic within the home area network when there are other traffic available in the network. First of all, I would like to give a brief description about the smart grid. The smart grid, as it is envisaged, it is the next generation energy grid, which is required to be reliable, affordable, globally competitive, efficient, and capable of accommodating renewable energy sources. This is how the Department of Energy of the US government defined smart grid at the very beginning. However, currently grid operates only with two signals, that is current signals and voltage signals, basically voltage signals and frequency signals. But we can't do much with those two signals alone. Therefore, we need to have another information system that is going parallelly with the grid, encompassing all subsystems of the grid and providing near real-time data to decision-making systems. For the ease of designing and for comprehensiveness of the design, NIST, National Institute of Standards and Technology, have divided the smart grid into 7 subdomains. They are customer, especially now customer is the people who are using energy, markets, the people who will be dealing with different types of energy markets, energy systems and information provision, service providers, operations who are connecting different kinds of aspects of the grid, then bulk generation, transmission, and distribution, mainly done by the utilities. Now, my research area focuses on customer subdomain and especially the systems residing in the customer premises. In the smart grid arena, customer subdomain should have an information system to interconnect all devices which are available in the household energy system. This can be the existing home area network, that is what we are researching, or it can also be a different network which is specifically built for this purpose. In smart grid, customers are active participants, unlike in the normal traditional grid, especially because they will be changing their energy consumption behavior according to the requirements of the grid. In addition to that, they will have distributed energy resources such as green energy sources like PV panels, small scale wind turbines, sometimes even non-green energy sources like small generators and so on. Additionally, they can have storages as well. And the main feature of these customers in smart grid is that they are capable of responding to sudden changes in the grid. Now, changing a customer's usage pattern according to the requirements of the grid is called demand response. And customer is in a demand response program, a customer is expected to modify consumption when there is an energy imbalance in the grid or any other situation, a critical situation that may arise in the grid. Once we have these kind of requests, the system should respond within an acceptable time limit, because otherwise the grid can go from a balanced state to a critical state, and it may shut down. And responses, the delivery of responses also should be done in a high reliable way. However, communication itself consumes energy. So when we build an information system which is running parallelly with the energy grid, it also will consume a significant amount of energy. So what we have to do is we have to try and reduce communications and try and lower the transmission power as much as possible. However, when we lower the transmission power, it reduces the reliability of the communication. A home area network, there are, of course, a variety of home area networks available across the globe. However, what we are referring to here as home area networks is the one which we are going to use for smart grid communication. So it will act as the customer premises infrastructure, connecting all the devices which are consuming power, generating power, and storing power. Home area network can have two interfaces. The first one is smart meter, that is a general interface which is provided by the utility for the purpose of advanced meter reading. In addition to that, it can deliver price signals from the grid to home area. In addition to that, there can be another interface which is called energy service interface, which is open to be connected with any third party with whom we may enter into contracts. They can also provide energy information management. Now, when we talk about the architecture of demand response, grid sends out requests. Usually there are 4 types of requests: price communications, grid safety or integrity signals, DER support, and other signals. Each of these requests accompany a ramp period which is defined with it, which is the actual acceptable delay of responses. However, when currently, according to the specifications, this ramp is considerably large, but with more renewable sources, there is likely to be a lot of variations in the grid, and the ramps are likely to become shorter, and there can be more frequent demand response requests as well. When we consider HAN gateway, home area network gateway, it can be the energy service interface. It receives the requests and relays to the devices, and it can collect information from the devices and send back to the grid. And if the HAN gateway has decision-making capabilities, it can participate in more intelligent responses like bidding for possible responses, and obeying the request at a very high level, and so on. However, what we are trying to do is to study the suitability of existing Wi-Fi networks for this purpose, so that the requirement for a separate network can be avoided, because having a separate network will definitely increase the global energy footprint. What we used here is a simulation setup using MATLAB Simulink software. We have designed a hand on a single computer with a hand gateway with 25 nodes to represent household devices. Arrival of a DR request is simulated by a random event, and these random events are 1 second apart for the purpose of our simulation setup. However, in real life situation, there won't be demand response requests every second. In the simulation setup, gateway broadcast requests, because that is only one-way connection communication, and requests are simplified into 3 categories. So for load requests, storages, and generations.
Dear presenter, you just have 2 minutes left.
Sure. And nodes are also one of these types. They only respond to their relevant events. And acknowledgements and responses are unicasted, they are addressed, they are not broadcast. So requests are 14 bytes, acknowledgements are 21 bytes, and responses are 21 bytes in this simulation setup. And when a response is not acknowledged, it will be resent 3 times before it is timeout. And the normal Wi-Fi CSMA CA is used with physical and virtual sensing, giving hand gateway a priority in communications. Simulation, the 25 nodes consists of 8 type 1 nodes, 6 type 2 nodes, and 11 type 3 nodes. And they are placed 100 meters away from the hand gateway. And 100 requests were sent by varying the available capacity of the bandwidth of the Wi-Fi network. And the results show that when there are no other traffic, results are very smooth. They show that a capacity of around 3 megabits per second is sufficient to have a very reasonable delay. But with other traffic, the variation is different, because it's not uniform like in without other traffic. And of course, with other traffic, there is a significant amount of packet loss as well. However, most of the packet loss is observed in acknowledgements rather than in responses. So what we can prove using this research is that the existing home area networks, Wi-Fi, normal Wi-Fi home area networks can be used for smart grid communication while having other traffic in the network. And of course, the packet loss can be overcome using historical data, that is by copying previous data into the latest data set. And effect of DR traffic on the network is minimal, so that other traffic will not be affected by the availability of demand response traffic. Okay, that's all. Thank you.
Sir, you need to unmute yourself.
So Dr. Dey, you are muted.
Yeah, thanks for your presentation. I don't have that much of knowledge of smart grid, but still as a layman, I'm just asking one question.
Yes.
I mean, can this whole thing we can do in NAN also?
Yeah.
I mean, not only for hand. If I talk about NAN, the neighborhood, then also the same thing can, I mean, we can study.
Yes,
Because there
that
is
is
also another various different kinds of, I mean, traffic. Like once it's passed through some smart meter.
Yeah, that's right. Now, actually, our research group consists of several people, and another set of people are working on the NAN as well. But the problem is when we go out of the house, we have to stick to a certain bandwidth, and we have to make sure that it doesn't interfere with other traffic which may be available outside the house, outside the home. And actually, we are the people who are working on neighborhood area network is currently focusing on ZigBee,
okay,
rather than just Wi-Fi.
Yeah. Okay. So I mean, for WAN also, for HAN also, and NAN also, different researchers are working in your.
Yes.
Okay. Fine. Because that, I mean, that I think the you know, these things are different. This interference is also different.
Yes.
Okay.
Yes, and
Thank you. If any
security is also a big issue, no?
Big issue.
If we have two households communicating with each other, there may be a problem.
Correct. Thank you. Anyone having any question? Thank you very much.
Thank you. We'll move forward. So our next presenter is Sri Ariyanti. I've unmuted you. Can you hear me?
Okay.
Your voice is not audible. Yes, your slide is visible.
Okay, thank you.
Yeah.
I would like to say thank you for the host opportunity to present our paper. Okay, in this opportunity, I would like to present our paper, Visible Light Communication for 6G Technology, the Potency and Research Challenge. And so first, this slide consists of introduction 6G theory, the potential use of VLC for 6G, research opportunities and regulatory challenge, and the last is conclusions. We know that data traffic continues to increase especially after 3G technology release. This is because 3G offers internet service that provide various application. The increasing of traffic data lead the innovation technology to compensate the increasing of data traffic. So 4G technology and then 5G are the solution to increase the good quality of services. Even though 5G technology offers high data rate up to 20 gigabit per second and offer various applications, it has the weakness, high cost, and infrastructure development. The new technology will be designed to provide solution for the technological limitation of 5G. 6G is expected to be able to ensure perfect use more than 5G, and 6G is predicted to emerge in 2025. And then this is VLC as a candidate of 6G technology. And the first standard of VLC is by Chieta from Japan in 2007. And then IEEE 802.15.7 was released in 2011. This IEEE explaining VLC topologies, modulation, physical layer, MAC layer, dimming, flicker mitigation support, a functional overview, and security. And what are the advantages of the VLC technology? This is unlicensed spectrum, low cost, and low power consumption. And also this high bandwidth, so that's it. It's the opportunity to for support high data rate. And this research to envision the potential use of visible light communication for 6G technological platform. This method exploratory review. And then I would like brief 6G theory. According to SART, proposed 6G technology Yeah, there are use case of 6G technology are mobile broadband reliable low latency, which not only provides low latency communication but also offer efficiency, reliability, and pace. And then massive ultra reliable low latency communication, which is combination of URLLC and MMTC, and provides higher quality and reliable service. And then human-centric service, in which the realization of the use case is targeted by quality of physical experience. So this is the use case that support the quality, that combination of quality of service and quality of experience. And then multi-purpose 3CLS and energy services. This use case will provide convergence of communication, computing, control, localization, sensing service, and energy for small device through wireless energy transfer. And for KPI of 6G, according to Eric, is the downlink of data rate is more than 50 that of 5G, and for the mobility if twice than of 5G, and the operating frequency range up to 1 terahertz. And 6G network, the Jordanese 6G network architecture that consists of efficient and low power network operation, disaggregation and virtualization run, extreme multi-connectivity, and cell-less architecture. And the cell-less architecture is supported by VLC, of course. And then proposed 6G network consists of satellite network with 5G network, combination of 5G and satellite. And what are the potential use of VLC for 6G? Features part of 6G are a heterogeneous network, much and security. For heterogeneous network, like the 5G platform, 6G will also support heterogeneous network, including metrocells, microcell, picocell, and femtocells for indoor areas. In such case, VLC is suitable to be applied in indoor room to support high capacity data platform. So one example of the heterogeneous network is hybrid Wi-Fi versus VLC. And then a much higher data rate. VLC spectrum band is between 430 terahertz until 219 terahertz. So it's creating a bandwidth range about 360 terahertz. So this considerable bandwidth shall give a high data rate that approximately 1 terabit per second. And then security. The physical layer of 6G technological security provides a layer defense, and VLC is argued to have better security than other wireless technologies. And VLC coverage is limited the device that is exposed to the light. Therefore, there is a lower possibility of security vulnerabilities than RF technologies. And the example of 6G that's supported by VLC are intelligent transport systems, smart city and smart homes, telemedicine, and underwater communication. And from our research that we find the research opportunities. The first are integration of VLC with another communication standard, and 6G technology will emerge to provide cost-efficient solution in telecommunication infrastructure development and offer a very high data rate. The integration of VLC with existing communication standard is necessary to support the efficient of network development. And then the second, interference issue with ambient light source. We know that PLC is susceptible with interference from natural and around light. Therefore, research is needed to overcome this disorder. And the third, Hanover, the research about Hanover is needed to improve quality of experience and intercell interference mitigation. If many VLC are applied in the future, the issue of interference between devices cannot be avoided. So those interference are caused by a number of adjacent VLC device. And the next for research opportunity, backbone network design. Some of research support optical based wireless and another purpose the PLC. So we have to research about maybe where are the physical of both of them, and then increasing data rate. There are so many research so that the data rate that can be achieved by VLC is less than 100 gigabit per second. However, the expected downlink data rate of 6G technology achieve more than 1 terabit per second. The research about increasing data rate is very needed until it meets the 6G requirement. Then, for the regulatory challenge, regarding VLC application for vehicle communication service, an automotive standard is needed to enhance driver safety and encourage environment that are promising for the market. And there is also need to develop link with other relevant regulatory bodies to ensure the compatibility of VLC with any trend, such as MICT, Ministry of Industry, Academy, Research Agency, and another related institution. And for so the regulator also considers about spurious of emission, and because it will cause interference in other RF spectrum bands, and then standards about safety so that VLC don't produce any harm for electromagnetic interference.
Dear presenter, yeah, you just have 2 minutes left.
Yes, and the conclusion, this paper has discussed the potential use of VLC for 6G technology platform and its research challenge. So, some technical aspects that suggest that VLC is compatible with 6G technology are its ability to support heterogeneous network, its higher data rate, its promise of reliability, security, and its offer of service application underlying of 6G use case. And for the research challenge for VLC, like interference with ambient light source, Hanover issues, intercell interference mitigation, backbone network design, and the need to develop a method to increase the data. Some topic proposed for regulatory for VLC are human safe standard, automotive standard, consideration of spurious RF emission, and the ability to avoid interference with other expectation. Thank you. If any question?
Thank you very much. Just again, I have only two questions. So one question is, why not FSO? I mean, free space optical communication.
To be candidate of CG, you know?
Yeah. Am I audible? Once we talk about 6G, then why not this FSO?
I think FSO is backbone, as a backbone. So that's why in Indonesia, FSO is optical.
There are few studies, though I am not from this background, but still, I mean, just curious. There are few studies where actually people tried to hybrid the FSO and the LVC,
Oh,
VLC.
yes.
So yeah, I mean this light communication. So how it actually works? Means is it effective? What do you think?
Pardon, can you?
If we hybrid this FSO with VLC, do you think it is effective? Because there are few
So that's
studies
why
are
this.
there.
So that's why it needs to be researched. So we have to know, is it effective or not, because there are so many or some of study about hybrid VLC, that combination of FSO and VLC, and we have to teach about the feasibility of that.
Actually, that's why I'm telling these things, because if you talk about FSO and VLC and FSO VLC as a comparative, I think that will be much more effective. Anyway, thank you. If anyone having any question, please.
Yes, thank you for your presentation.
Thank
So
you.
we'll move on further. Our next presenter is Abdul Rahman Hafiz. I have unmuted you, sir. Are you able to hear me?
Yes, I am. Can you hear me?
Yes. You can begin with the presentation. Unmute yourself again.
Okay.
Yes. Share your screen, sir.
I'm trying. Open system preference. Okay. Be able to record. Okay. Do you see my screen?
No, I don't.
Not yet. Oh.
I think so, Abdul. You can just go ahead with the share screen in the below side.
Yeah, I did click on that, but
and you can
I'm
permit
not
your
sure.
presentation slides. That's it.
Yeah, well, my computer is asking for permission to share the screen. I don't know what's going on.
Yes, you have to just give the permission first.
Okay. Start. Share screen. Okay.
Yes,
You
perfect.
actually see my, you see it?
Yes. Make it full screen and go ahead.
Fine.
Okay, perfect. Hello, everyone. My name is Abdul Rahman Hafiz. I'm a PhD student at Towson University, Towson, Maryland, USA. And my
yes,
academic
might be your. Yes.
Go ahead.
Please
okay.
Continue, please.
Sure. Well, my topic is about training elderly with mild cognitive impairment to use the Senior Book mobile app. And this is the second pilot study. We were repeating the pilot study because we've realized some drawbacks, such as we had to change actually some of the research instruments. And they were major changes. That's why we are repeating the pilot study again. So we've replaced the mobile app prototype itself, as well as the intelligence test. So today I'm going to talk to you, I'm going to give you a brief introduction about the topic, and then I'll talk to you about the pilot study design. Then I'll move to training procedure and phases. And then I'll talk about the Senior Book app design itself and compare it to the old one then we'll share the results and conclusion. So this paper reports the second pilot experiment conducted after revising the research instruments based on the major flaws recorded from the first pilot study. So as I mentioned, there was a problem with the mobile app prototype itself, which is the main thing that we are trying to train the elderly with, as well as the intelligence test. The first one was very overwhelming, and there were some, it was a very complex test actually. It was called the Wonderlic test. So that test tested their mathematical knowledge, language, as well as their cognitive abilities. Whereas the new cognitive test that we substituted, which is called the cognitive function test, was only cognitive focus test. So we conducted this research using the same actually subjects, 5 cognitive elderly, age 65 and 70 years old. So they were re-invited back to participate in the second pilot study. So the senior book mobile app prototype was mainly designed to resemble the activities frequently performed in popular social media apps. So we wanted to train those elderly to use or to be familiar with social media, and probably or eventually use social media independently on their own if they benefit from this study. And while we tested those participants, all of them scored, when we tested their cognitive abilities, all of them scored within the mild cognitive impairment range. So the training classes, we had 3 different training levels based on the mobile app itself. So the training programs involve training class with a different version of social media mobile app prototype, including basic app and the basic app with embedded instructions, which is called the limited version, and the basic app with embedded instructions and narrations, which is called a premium version. So basically, I have given those participants a class using visual aids such as PowerPoint slides, give them an overview about the prototype, the senior book mobile app prototype, and show them the difference between the old version and the updated version. They also were provided with flashcards they could review during class and a list of activities that they were required to perform. So, and the training procedure went through 3 different phases. We started by training, and then participants were asked to go back home for self-study period for 2 weeks, and then come back for observation meeting, which was very similar to the training session, because they had to come back to perform the same activities they've been studying during the self-study period as well as the training class. So the training class was an introductory meeting talking about social media in general. It took us 15 minutes. And as I said, I showed them the updated version of the senior book mobile app, and then provided them with the task list they needed to perform, and also allowed time for discussion between tasks as well as at the end. And I used some screen recording tool to record their screens while they are performing the activities. Phase 2 was the self-study period. They went back home for 2 weeks with a pre-designed or pre-designed list of activities, and they were asked to record their diary of usage. Whenever they logged in or they accessed the mobile app prototype, they had to take notes actually about their experiences, as well as use the recording tool to record their screens. Phase 3, the observation meetings, they were invited back after 2 weeks. Oh, I'm sorry. And in the self-study period, although it is 2 weeks, but they had to only participate or log in 3 times a week for 10 minutes each time. So total was 1 hour actually for the whole 2 weeks. And they came back for observation meetings for another hour. So the observation meeting was basically to figure out whether cognitive impaired participants were able to return information after a certain period of time, and also check the success rate based on the completion of the tasks and whether they needed assistance while they were performing those tasks. So here is some of the pages within the app design. So if you look at Figure 1 was the old version of the senior book mobile app prototype, which was consisted of screenshots of the Facebook app. So, and was designed on Envision platform, whereas I used Adobe XD to repeat actually and rebuild the whole app from scratch. When you look at Figure 2 to 6, they were all designed from or using the Adobe XD, which is more sufficient and vector-based. Vector-based images, and so they are actual buttons and actual pictures embedded in the design. Whereas the older version, the Envision version, which is Figure 1, was screenshots, and each button was connected via a hotspot. So I created hotspots in order to create buttons, whereas the newer version, each button is actually an actual button that is represented inside the app. Has full functionality and everything. The other thing was actually the narration feature or functionality. With the older version, I had to use a third-party app in order to activate narration. But if you look at Figure 3 here,
dear presenter, you just have 2 minutes left.
Oh, okay. So in Figure 3, you see that there is an actual narration button, which is the speaker button here, where they can hear the instructions. And also another thing within this design is that those pages are long and they can scroll up and down to view more contents. So here I just included some of the differences between the two, which I mentioned some of them actually already. So I used Adobe XD, and I have created 3 different versions, the basic and premium and limited. So what I did is that I created the premium version, which included the instruction buttons and narration buttons. And then for the limited version, I just removed the narration buttons and kept the instruction buttons within the design. And then for the basic version, I removed both the instructions and the narration buttons and saved each version independently, separate from the others. And text capability is actually disabled. Participant has the opportunity to share stickers instead of using an actual keyboard to text and write a text message. So for the results, actually, the cognitive was a better alternative than the Wonderlic. One participant found it challenging to remember to access the mobile app during the self-study period. Another needed longer time to perform the activities. And one participant actually benefited from the instruction narration buttons, which helped them to successfully finish the task actually and move forward. Overall, 2 participants rated the overall ease of use as neutral. 1 indicated it was difficult, and 2 others said it was easy. So as a conclusion, the overall design of the experimental research appears to be sufficiently accepted, beginning with the intelligence test and the senior book mobile app, as well as the training. All participants indicated that or said that training was very important, which made them confident that and aware of the actual process and actual mobile app prototype, and made them convinced to participate. And the limitation of this study was the small number of people, of participants, which made it impossible for the research to generalize on any issues actually. And also the other limitation is that I have used the same people who participated in the initial pilot study. Because of the current situation, I couldn't recruit more people. And for your information, actually, this pilot study showed very positive results and will be used in the main experiment for my research, which will be conducted on 30 different participants. And if you have any question, please ask. Thank you so much.
Thank you so much. Hello.
Yes.
Yeah. Am I audible?
Yes, Dr. Dey.
Okay. Thank you very much for nice presentation. Do you think that the demographics and the ethnicity will make any difference for the obtained results?
Can you repeat your question, please?
Do you think that the ethnicity or the demographics of the subject will make difference in the results?
I don't think so, because our focus was actually targeting elderly people and with the same cognitive impairment or similar, because they were all mild cognitively impaired, and also with intermediate knowledge of social media. So we weren't including any savvy social media users or non-social media users.
Actually, I am asking because as it is a generalized study, so the data, once you talk about the data pool, it should be, demographics, there should not be any kind of demographics limitation. And one more thing, how can you tell this system is more robust?
The app?
Yeah.
How can I tell it's more robust, you said?
Yeah. From functionality point of view, from any other point of view, it's a robust one. Because as it is a very limited data study, it's I understand that it is a pilot study. The data number is very less. So there should be one robustness checking, means how robust the app is. Okay,
So,
thank you. Yeah, please.
So if you were talking about the limitation of the app, is that what you're saying?
Not limitation. But see, what actually my first question was like this, because as it is a study of a particular age group, I mean, is it irrespective of the demographics, ethnicity, it will work fine? Or the second question is, I mean, the robustness, how robust the mobile apps is.
The speed you said?
Not only speed, I mean, robustness means usability, and I mean, to go for a further enhancing this thing means how robust the system is, susceptibility.
Yeah, well, there were some issues actually regarding the design. Like some buttons weren't functioning. The older system was a little bit slow and couldn't recognize tabs. So those things were like, we overcome those issues. Like once I replaced the platform, I realized a better tab recognition, as well as I took care of all the buttons that they weren't working.
Okay, fine. Thank you. Thanks.
Thank you so much.
Yeah, thank you.
Thank you. Thank you for your presentation. So our next presenter is Maureen. I have unmuted you. Are you able to hear me?
Yes.
Yes. You can begin with the presentation. Yes, it's visible. Yeah.
Do you see my presentation?
Yes, you can go ahead.
Thank you. Thank you for the introduction. I'm Mari Matsumoto, and this talk is about speeding up fully homomorphic encryption on smartphones. Here is the outline of my presentation. This presentation has 7 parts. I will start with overview of my research first. Then I will describe 3 designs. Fifth, I will move on to the experimentation. Sixth, I'm going to talk about conclusion. And finally, summary and the future work. I'd like to begin with overview of my research. Here is background of my research. Statistical analysis using cloud services to utilize sensor data acquired by IoT devices such as smartphones has become widespread. Since highly confidential data exists in sensor data acquired by IoT devices, device users want to avoid disclosure of personal data. On the other hand, the data analysis use get data analysis results. The most important point here is fully homomorphic encryption can satisfy the needs of both sides. Fully homomorphic encryption, called FHE for short, it has the ability to calculate between encrypted data. The disadvantage of FHE are its long processing time and large ciphertext size. As I will explain later, there is a cipher called SHE that limits the number of multiplications. So how slow is FHE processing and how large is the FHE ciphertext size? I'd like to draw your attention to the next slide. This graph compares the encryption algorithms and the encryption time. The plain text size is 1 byte. The algorithms used for comparison are AES and Trivium and FHE introduced later and FHE. This graph shows that FHE is much slower than other algorithms. Here, this graph compares the encryption algorithms and the ciphertext size. This graph shows that FHE ciphertext size is much larger than other algorithms. Due to two shortcomings of FHE, implementation on IoT devices with low computing power is a challenge. So the purpose of my research is creating a high-speed and low-traffic system for IoT devices. My next slide shows the previous work. Lauda et al. Have proposed a combination of AES and FHE to speed up encryption and reduce communication volume. The idea of the previous work is that instead of using FHE, which is slow and heavy traffic, client use AES to encrypt plain text. The server converts AES ciphertext to the FHE ciphertext by using the property of FHE. My research has 3 features. First, I focus on using IoT devices as clients. Second, the previous work has used AES, but in my research, I implemented Trivium. Third, I compare 3 different designs, including the previous work design. So I will move on to the next section and talk about 3 designs. I'd like to introduce design 1. Here, design 1 is called FHE only. This is the outline of design 1. First, the data analyst generates the public key and private key of FHE and sends the public key to the client and the server. Second, the client generates ciphertext encrypted with FHE. Third, the client sends ciphertext to the server. Fourth, the server analyzes using ciphertext encrypted with FHE. Fifth, the server sends the analysis result to the data analyst. The advantage of design 1 is that it's a simple system. On the other hand, the disadvantage of this design is the client load is heavy. Then I will explain the second design. Here, design 2 is called Trivium plus FHE. First, the data analyst generates the public key and private key of FHE and sends the public key to the client and the server. Second, the client generates a Trivium key. Third, the client generates ciphertext encrypted with Trivium. Fourth, the client encrypts a Trivium key with FHE. Fifth, the client sends ciphertext and encrypted key to the server. Sixth, the server converts ciphertext encrypted with Trivium into ciphertext encrypted with FHE. Design 2 based on previous work. The advantage of design 2 is only keys are encrypted with FHE, but it is a little complicated system. Here, I'd like to introduce Trivium. This is a cipher selected in the evaluation project of Stream Cipher called eStream. Key length is 80-bit. The reason for choosing Trivium is that the decryption process of Trivium and that of FHE are a good combination. Then I will explain the third design. Here, design 3 is called SHE plus Trivium plus FHE. First, the data analyst generates the public and private keys of SHE and FHE and includes the private key of SHE with FHE. Second, the data analyst sends the public key of SHE to the client and the private key of SHE encrypted with FHE to the server. Third, the client generates a Trivium key. Fourth, the client's ciphertext generates ciphertext encrypted with Trivium. Fifth, the client encrypts the Trivium key with SHE. Sixth, the client sends ciphertext and encrypted key to the server. Seventh, the server converts the Trivium key encrypted with SHE into the Trivium key encrypted with FHE. Eighth, the server converts ciphertext encrypted with Trivium into ciphertext encrypted with FHE. The advantage of design C is that client uses SHE instead of FHE. The disadvantage is it is a little complicated system and server load is heavy. Here, I'd like to explain somewhat homomorphic encryption. Instead of limiting the number of multiplication, SHE takes less time than FHE and ciphertext size is smaller than FHE. Now, I will move on to the next section and talk about experimentation. This table shows the performance of machine used in the experiments. For the experiments, the Google Pixel 3 was used as the client and the MacBook Pro was used as the server. The three comparisons were made between FHE only, Torribian plus FHE, and SHE plus Torribian plus FHE. First is execution time by client. Second is file size sent from the client to the server. Third is execution time for convert ciphertext to FHE ciphertext by server. This graph shows execution time by client. According to this graph, execution time of FHE only increased largely. On the other hand, that of SHE plus Torribian plus FHE is much faster than other designs. Then, this graph shows file size sent from the client to the server. According to this graph, file size of FHE only increased largely. On the other hand, that of SHE plus Torribian plus FHE is much smaller than other designs. This graph shows execution time for convert ciphertext to FHE ciphertext by server. In FHE only, the conversion process is not performed. The important point here is that the server load is heaviest in SHE plus Torribian plus FHE. This is a table summarizing the experimental results when the plain text is long. In this case, it is effective for client in the order of SHE plus Torribian plus FHE, Torribian plus FHE, FHE only. This table summarizes the experimental results for short plain text. In this case, it is effective for the client in the order of SHE plus Torribian plus FHE, FHE only, Torribian plus FHE. Now, I'd like to turn to conclusion. In conclusion, from these experimental results, SHE plus Torribian plus FHE is most effective design for data utilization in IoT devices. These are two reasons why you should choose this design. The first reason is that this design has less client load and traffic. Furthermore, the server load is heavy in this design, but performance of clients such as IoT devices is generally lower than that of servers. So it is important to reduce the load on the client. Now I will talk about summary and future work. In my research, I implemented and compared Torribian, SHE, and FHE combinations with the purpose of speeding up FHE on smartphones. The future work is to consider a system that has a high security level and reduces the load on the client. That's all for my presentation. Thank you so much for your kind attention.
Yes, thank you. Thank you for the presentation.
Yes.
Any questions, anyone? Okay, so we'll move further, Marine. Thank you. Sir? Just a minute, huh?
Hello. Yeah. Thank you very much. Thanks. Nice presentation and well organized. Just one question. Hello.
Yes.
Yeah. So what is your next plan to, make it excellent, the server load?
It's my presentation and I implemented Torribian, but its key length is 80-bit. Its security level is a little low, so I'm trying to implement AES or more long ciphertext algorithms.
Okay, thank you. Next one, please.
Our next presentation is by Raymond. I have unmuted you.
Yes, thank you. Now I will share my screen.
Yes, please.
Is my screen visible?
Yeah, yes, yes.
Okay, thank you. Hello, everyone. My name is Raymond R. Saragi, and my co-author is Suyoto. We are from Department of Informatics at Atmajaya Yogyakarta University, Indonesia. Now I'm going to present our study entitled Development of Interactive Mobile Application with Augmented Reality for Tourism Sites in Batam. In some countries, tourism has become one of the fastest growing economic sectors. Indonesia is a country that uses tourism as the nation's source of income. According to the data published by the Ministry of Tourism and Creative Economy of Indonesia, in 2019, more than 16 million foreign tourists visited Indonesia. There are 3 locations have the arrival numbers that reach above 1 million, and one of them is Batam. Batam is in the Riau Islands province, Indonesia, and has become one of the tourist destinations in Indonesia. The government of Batam City has made several efforts to promote tourism in Batam. The promotion uses such as brochures, videos, or other types of digital advertisements. The emergence and expeditious development in mobile technology, as we know, have changed human life. People use mobile devices for reading news, social media, or playing games. In recent years, augmented reality became the trend in developing mobile apps for tourism. Augmented reality provides new experiences and increases the enticement of tourism sites. Besides that, augmented reality interactively displays information. As we all know, the COVID-19 pandemic brings a significant impact on the world, and the COVID-19 pandemic also affects the tourism sector in Batam. The augmented reality technology in mobile application offers advantages that can increase the enticement of tourism sites in Batam. Therefore, the focus of the study is to propose an interactive mobile app with augmented reality for tourism sites in Batam. Then the proposed method. After the COVID-19 pandemic, it is expected that there will be an increase in tourism trips. Because after months of undergoing lockdown and staying or working at home, people want to travel to relieve boredom. They also certainly want a new experience that can excite them. This study researches utilizing augmented reality and mobile applications for tourism in Batam. The benefits that the augmented reality provides gives an idea to apply the technology for tourism in Batam. The utilization of augmented reality might be used as a medium to promote tourism in Batam. The AR mobile prototype creation process is shown in the diagram below. First, we design the use case diagram, and then second, we make the user interface design. And then the third, we develop the prototype based on the design that has been made. And last, we test and evaluate the prototype. The application's concept is shown on the side figures. The first, the user can see a list of tourism sites in Batam. The application will help tourists to know tourism sites in Batam, the location, and information related to them. And then the user uses the camera and directs it to an image target. Augmented reality uses the camera in a mobile device to scan the target image. The mobile app uses the marker-based method augmented reality because, according to the previous study, it gives better accuracy. And then these are the results. These are the design of the prototype. There is the main screen design, the site information screen design, the map screen design, and the AR screen design. Next, these are the display of the prototype of the application based on the user interface design. There is the main screen, and then the site information screen, the map screen, and the augmented reality screen. The main screen consists of a list of tourism sites, showing the list on the main screen, eases the users when they want to find the information on tourism sites in Batam. The card displays an image of the tourism site so that users can see an overview of the tourism site. Users can scroll down to view more, and the users can click on the card if they want to know the detailed information about the tourism site. And then to show the map, the users click on the map button and the app will show the location of the selected tourism site. The augmented reality screen lets the user scan a specific image marker to show the AR object associated with the image. Therefore, the visitors have interactive participation in the tourism site. And the conclusion, we propose an interactive mobile application with augmented reality for tourism sites in Batam. The application provides a list of tourism sites in Batam, the information regarding the tourism site, and the map of the tourism site. The contributions of the study are: the study offers a prototype of an interactive mobile application that uses augmented reality. The design of the application is to ease users in finding information about tourism sites in Batam. And last, the augmented reality provides interactive participation of visitors by scanning and displaying the objects from marker images. That is my presentation. Thank you.
Thank you.
Yes.
Dr. Day, your comments?
Hello. Yeah.
Hello, thank you.
Yes.
Yes. Nice presentation. What's new in this?
Yes, because our mobile app, we proposed the augmented reality because previously the Batam city government haven't have the promotion from such as mobile application that uses augmented reality. Therefore, we propose this.
Okay. So it can't be used for generalized purpose. It is very much specific to a town or a city, correct?
Yes, only specific to Batam city.
Okay. Okay. Anyone having any question?
Might be not yet.
Our next presenter is Diego. I have unmuted you, yeah. So you can begin.
Thanks. I share my screen, please.
Yes, please.
IT governance and green IT, a systematic review. Author, Diego Cordero. Introduction. Information Technology Governance, ITG. Now, the overarching role of IT governance is to provide strategic oversight and guidance around IT matters. Essentially, IT governance provides a structure for aligning IT strategy with business strategy. IT governance are used by organizations, are dedicated to organizational management and IT governance, reach degrees of maturity. On the other hand, green information technology, ITG, every day, a greater number of organizations around the world are implementing new practices about green IT. It is developed in different ways by countries throughout the world. The overall green IT maturity level is low, and the index across all industries in all countries is 56.4. The best performing country of the four sovereign is the United Kingdom, with an overall green IT readiness index. The most significant findings is the relative lack of maturity of green IT policies, practice, and technologies in every industrial sector in every country. However, actually are disconnected. The problem involves analyzing the best practice of IT governance that are compatible with green IT practice to have a new framework that brings together governance and green through a taxonomy. Above these factors, the authors show a taxonomy that classifies the most important investigations about governance and green IT. The authors had studied around 100 selected researches about this area. The article pretends schematize that information about green IT practice and IT governance framework. In detail, the steps are the following. First, define the themes, green IT and IT governance. Second, elapsed time, last 10 and 20 years respectively. Third, search keywords about IT governance and green IT. Fourth, build logical expressions using keywords. 5. Select scientific databases beginning with Google Scholar, ascending to Elsevier, IEEE, Explore, Springer, and so on. 6. The articles founded are filtered, title, abstract, diagonal reading. 7. Of the most important articles is extracted, publication date, authors, abstract, methodology, users pull things, article gaps, solves for unsolved problems. 8. Create a table and propose a new taxonomy, and so on. 9th, discussion. About green IT. Organizations around the world started recognizing the importance of concepts of sustainability that are classified into 3 aspects, such as environment, social, and economic perspective. Several researchers define green IT as the analysis, design, and implementation of computer hardware efficiently, with less impact on the environment. Through the use of information technologies, different aspects can be supported, such as hardware supply chains, electrical power, reading automation, software, technological waste, among others. The movement of green technology is becoming more aware in organizations, which are more responsible for taking care of the environment. However, the success of the aforementioned initiatives depends on the relevance of the strategic and decisive framework, like a new framework to implement both IT governance and green IT administration. About IT governance. IT governance is implemented by structures, relational mechanisms, processes. The structures consider responsibilities, functions, and roles for IT managers. Relational mechanisms consider the type of cooperation between the organization and IT, collaborative learning, and strategic interaction. Processes in the process are COVID, ITIL, VAL-IT. The systematic literature review methodology. Google Scholar database research some articles. Search established between from 2009 to 2019. First search using keywords. Green IT practice, Green IT framework. Second search using keywords. IT governance structures, IT governance processes, IT governance relational mechanisms. Resulting 500 articles, 1,020 articles. After reading to locate the most important right and specific definition of the green IT practice and IT governance. After, authors gave special attention to editorial and publishers such as IEEE, Springer, Elsevier. At the finish were selected 80 research papers on green IT, 85 research papers on IT governance. Several articles study more than one topic. Some researchers focus only in IT governance or green IT, but not people studies. Figure shows overlap between topics for IT governance. Framework at the left, practice at the center, model at the right. Figure shows overlap between topics of green IT. Framework at the left, practice at the center, model at the right. At this table, we have IT governance articles 89, Green IT articles 18, years from 2000 2019. Number of works, list of research works. Taxonomy for each metonyms, discussion, and conclusions. Throughout this investigation, the authors proposed the factors to consider when studying green IT and IT governance, such as structures, processes, relational metonyms, practice, politics. Moreover, the authors proposed a classification of the research on two ways. First, IT governance frameworks processes-oriented. The processes contain activities that achieve a purpose. There are several frameworks that are useful reference source for information about IT processes the following. COVID, IT, while IT. Option 1, IT governance process-oriented with green IT practice. And the second option, IT governance frameworks, behavior-oriented IT controls. Controls are presented throughout the organization. Control activities are part of the processes by which an enterprise strives to achieve its objectives. Compliance, financial report, social, safety, health, operational sustainability, environment. Popular framework is ISO 38500. Option 2. Option 2. IT governance, behavior-oriented. Include green IT practice. Today's organizations and themselves find themselves facing a relative new challenge governing and managing sustainability. Since sustainability has become an important issue and is increasingly essential for business. Green IT practice help enterprise achieve and maintain eco-sustainability. Like any other business practice, green IT can be optimized for value, not only to the business, but also to the broader community when it's appropriately governed management. IT governance and management framework help enterprise standardize and control green IT so that it meets the expectations of the business. Thanks.
Yes, thank you. Thank you for your presentation.
Thank you for the presentation. Now I would like to invite Dr. Amit Joshi for the closing remark of the same.
Excuse me?
Yes, Diego, thank you for your presentation.
Thanks.
Hi, good morning, everyone, and hope you all are doing good. And this London currently is a very good climate. Summers are going on here, and if you are near about in this continent or in Europe, please do enjoy this summer, amazing summer. I understand that it's somewhere it's difficult because people are at home, but still, if you are nearby, please enjoy the time here. And once again, good morning, good afternoon, and good evening to one and all who are joined in this session, because everyone is joining from different places, so the time zones are different and all the things are different. But my for this session, my thanks are due to Dr. Nilanjan De, who has chaired this session and spared his time valuably. This is a token of appreciation from our organization to Dr. De, and he will be happy to receive it. Thank you, Dr. De, for sharing your. I believe and I personally understand that chairing a session digitally is much difficult because you need to concentrate on a single screen for a longer number of time, maybe around 100 minutes, listening to the people and then commenting on their work. So it's a really tedious task. But thank you very much for and I appreciate your efforts. Further, my thanks are also due to all the presenters who have presented their paper in this conference. And I understand that the cycle time of a paper when you submit to a conference and to when it get published is approximately 6, 7, or 8 months, depending upon the scenarios. But already we have passed 3 to 4 months when you have submitted, it was accepted, you revised the paper according to reviewers' command, and now you are presenting. I hope that another 2 to 3 months it will take to get it published by IEEE. We are in the final phase of submitting the e-copyrights. Already 70-75% authors have signed it. Only 20% are remaining, which we hope that it will be completed by the end of this week. We will upload the data to IEEE, and we expect the publication by, you can say, September last week or in the month of October. So thank you very much for presenting your papers, and you will also be receiving your conference certificate, your thank you letter, and your payment receipts in your mailboxes just after this session is over in just next 1 hour or so. So thank you for being so patient, and I wish you a safe time in whichever place you are. Do contribute to society how much you can, and wherever you find a scope to do, and wish to see you in a physical World S4 2021 in London. Thank you very much. Thank you.
Thank you, Dr. Amit. Now I would like to pass only one message to all the authors. For next 20 seconds, if possible, you can just turn on your camera so we can click a glimpse of World S4 2020 of this session. So if you are comfortable, kindly turn on your camera to all participants.
There is an amazing London in background of one of the authors. That's really great.
Yes. Thank you to all the participants.
Thank you very much. Thank you.
We'll look forward to close this session by secretary. Thank you.
Thank you everyone for your participation. Stay safe and stay healthy, everyone.
Thank you. Bye.
Thank you for your presence. Thank you, sir.